Geometry, Chapter 2, Section 2, Finding the Nth Term. So let's look at the concept of the function rule. The function rule gives the nth term for a sequence. So in other words, given a pattern, can we find the nth term? So here's our pattern. We've got the term in the pattern goes from 1, 2, 3, 4. In other words, the first term, second term, third term, fourth term, and so forth, and the value of that term. So term 1, the first term is 3, then it's 9, then 15, then 21. So what's the difference? How much do we go from 3 to 9? From 3 to 9, we go up by 6. 9 to 15, oh look, we also go up by 6. 15 to 21, we go up by 6 again. So the idea is, well, how can we find out, well, what some nth term is? Going up by 6 each time. Well, let's figure out an equation for this. And we're going to do this in 2 ways. First way, let's think about, well, what's term 0? What's its value? Well, if term 1 is 3, I just work backwards. Going from term 0 to term 1, it's got to be an increase of 6 as well. So if I'm at 3, and I went up by 6 to get to 3, what's 3 minus 6? The value of term 0 has to be negative 3. So every time I'm increasing it by 6, so 6 times n. n is my term, and then I add the 0th term, which was negative 3. That's the equation I can use to find the 100th term, to find the 23rd term, to find the millionth term. All I have to do is plug the number in for n. Let's try it out. Let's find out what 2 is. 6 times 2 minus 3. 6 times 2 is 12, minus 3 is 9. And it matches what I have for the value. Let's try 4. 6 times 4 minus 3. 6 times 4 is 24. 24 minus 3 is 21. So our equation is working. Well, let's look at another way we can create that same equation. So I already know I'm going up by 6 each time. So what I'm going to do is I'm going to set up my equation, 6n plus some unknown. This equals the value, we'll call v. So 6 times my term, my first term is 1, plus an unknown, equals my value, which was 3. So 6 plus c equals 3, so c is negative 3. This gave me my same equation, 6n minus 3. Well, let's look at another one. Let's see if we can create the same setup here. So here we go. Term 1 is value is 12, term 2's value 5, negative 2, negative 9, and so forth. So going from 12 to 5, I'm going down by 7. 5 to negative 2, down by 7. Negative 2 to negative 9, down by 7. I'm going to do this in both ways. I'm going to look at term 0. So term 0. So if I go down by 7 and I hit 12, that's 12 plus 7. So term 0 is 19. So my equation would be negative 7 times n plus 19. Let's solve that let's do this algebraically. So negative 7 times the term plus some unknown equals our value. Let's take our first known term. So negative 7 times 1 plus the unknown equals our value, which is 12. So negative 7 plus the unknown equals 12. So the unknown is 19. And I get the same equation. And we can double check to see if it works. Let's plug in 2. So negative 7 times 2 plus 19. So negative 7 times 2 is negative 14 plus 19 is 5. It is working. Now we're looking at something that's called function notation. We wrote out the equation. Now this is really looking at the terminology that we're using for this. The function notation is the rules for sequences which can be expressed as a function notation. F of n. F of n. That's what this is. F of n equals 3x plus 7. So in other words, I can plug in the 1 in here and get my value. So let's do that. So I plug in 1, so 3 times 1 plus 7. Well, that's 10. Let's plug in 2. 3 times 2 plus 7. So that is, we get 13. I plug in 3. 3 times 3 plus 7. I get 16. 3 times 4 plus 7. So we get 19. 3 times 8 plus 7. And here we get 31. Now I do 100. 3 times 100 plus 7. And we get 307. So I can pick any term, and I can figure out, well, what value is that by using the function notation. Now let's look at a little bit of algebra review. What is the equation of this line? We're going to put this y equals mx plus b. Remember, this is slope-intercept form. M being the slope, b being the y-intercept. Ran out of room there. Y-intercept. The y-intercept is where it crosses the y-axis. So b is negative 1. Our slope, we go up to over 3. Remember, slope is rise over run. So our equation, y equals the slope, rise over run, plus the y-intercept, plus the negative 1. So I'm just going to write minus 1. That's the equation of the line. Let's do another one. So again, y equals mx plus b. Our y-intercept is at 3. Our slope looks like we go down 4 over 3. So y equals rise over run, so negative 4 over 3 plus the y-intercept 3. And that's the equation of our line. And that is the end of this lesson.